Hi, my name is Cam Clements. I work for Siemens PS2, and I'm an application specialist with the weighing and feeding group. I'm here today to demonstrate to you our MSI single idler belt scale. This is a product demonstration that can be done in front of the customer with very little setup, and can show the advantages that we have with our scale over a lot of the competition. Included with the demonstration kit that you'll be receiving is the MSI single idler belt scale and a set of instructions. In the set of instructions we have a set of steps that need to be carried out in order to set this unit up ahead of time or in front of the customer, depending on how much time you have with your customer. On the second page is a step-by-step script that you can go through, memorize, try this ahead of time before you get in front of your customer, go through all the steps and demonstrate the capabilities of this scale. Also included are all of the interconnections that you need to connect the two load cells on the MSI to the BW500 integrator. Once you have the system taken out of the trunk of your car, you'll want to have it plugged in as far ahead of time as you can to make sure that the electronics are warmed up and that everything is warmed up. When you're setting up the demonstration, it's always best to have the MSI mounted or sitting on a solid floor as opposed to on carpeting. If you're on carpeting, the scale can move around a little bit as weight is being applied to the scale and removed from the scale, and this can sometimes cause a little bit of inaccuracy. Explain that to the customer that you're not sitting on a hard floor. Okay, if you have a choice, try and get on a solid concrete floor or a tile floor. Once you're ready to perform the demonstration in front of the customer, have the unit sitting and maybe not yet calibrated. Have the customer look at the display and see if it is reading 0. If it is not reading exactly 0, simply calibrate, do a 0 calibration, 0 and enter, watch the display. The calibration parameters that we have given you, the calibration should only take 3 to 5 seconds. So it's not a lot of time, but it's enough time for them to see that it is actually doing something on the display. Right now I'm displaying the 0 deviation. The calibration has been completed and there was no error. Press enter, press run, and we're back into run mode. The calibration parameters that we have set up for you are showing this belt scale as a bathroom scale. We can stand on that and see our weight displayed on the display. The rate display is set up to read your weight in pounds. The load display, by pressing the Alt display key, we can see the load display. The load display is set up to read your weight in kilograms. Everybody in North America knows how much they weigh in pounds. The rest of the world knows how much they weigh in kilograms. So we have both displays available. The next step is to stand on the scale. Have the customer taking a look at the display and stand right up on the scale on the two platforms, 1 foot on each side. The customer can see that it is now displaying your weight in pounds or kilograms depending on which display you are on. We have 2 load cells on this scale. It's like having 2 scales. Each load cell is like an independent scale. We then show the customer that it doesn't matter which side of the scale we're standing on. We can shift our weight from side to side, and we will see on our display that we're still reading the same value, regardless as to which side of the scale we're standing on. Most of our competition is also using 2 load cells. Most of our competition don't have this electronic balancing capability. When they are doing this side to side, you will see a difference in their weight. Okay, most of your customers have been told never to stand on a scale. Imagine what they'll think when you start to jump up and down on the scale and read the display and see that it has no difference in the reading than it did before. You can then get off the scale and the scale will return right back to reading 0 kilograms. The customer has now seen that this scale can weigh a person, fairly accurate. Have the customer stand on the scale. most people have a pretty good idea how much they weigh. Okay? Sometimes they're not weighing themselves fully clothed, so they're going to have their heavy boots on and they're going to weigh a little bit more. Some of the demonstrations in the past, we have actually made the scale so that it reads a little bit light, so as not to offend anyone. But we rather have it exactly accurate. And I always carry with me a small precision weight. This precision weight can be put on the display, on the scale, and see that it is reading exactly 0.1 kilograms, a 100-gram weight. You don't have to use a weight like this. You can use your cell phone or a pen or a screwdriver, whatever you happen to have, even the customer's coffee cup. Have them drink a little bit of the coffee, put the coffee cup back on, and you'll see that the weight has gone down a little bit, so that it is seeing very small increments in weight. Then get the customer to stand back on the scale. Okay? Have him stand very still with his hand out. We'll see on the display that his weight is being displayed, and it's very steady if he's standing still. Then have someone put the weight in his hand, and you will see the display go up by exactly 0.1 kilograms or 100 grams. This is showing not only the accuracy of the scale with reading large amounts of material and adding one more particle of material, but when we get off the scale again, we can see that it is still reading with the same accuracy just that one particle of material. This is showing how linear our load cells are. At this point, they're probably pretty impressed that we're able to see such a small weight. Try something else, a small coin. Try this ahead of time to make sure that it is reading. A small $2 coin in Canada weighs exactly 10 grams. So we can put that on the scale, simply set it on the scale on one side, and we will see the display has increased to show 0.01 kilograms. The load cells that we're using on our MSI scale are a triple beam parallelogram single point load cell. We are using these types of load cells with no moving parts. The MSI has no moving parts, no area for maintenance. Most of our competition do have moving parts or bearings or pivot points that do require maintenance and cleaning and lubrication. I'm going to demonstrate next what other advantages we gain by using this type of load cell. Included with the MSI demo kit is this stainless steel rod with a hole drilled in it and a string attached. What we're showing here is that the horizontal forces on the conveyor have no effect on the load cell reading. This is something that we're gaining that none of our competition can do as a technical advantage. The stainless steel rod is threaded on the other end so that it is attaching to the scale where the idler would attach. The idler sits above and has a belt running on top. The belt is creating horizontal forces onto the scale mechanism. What we're saying is that our load cells are impervious to those types of horizontal forces. Our load cell only sees the load on the conveyor. To demonstrate this to the customer, have this attached. Have your string sitting horizontally and pull on this string in the horizontal direction with enough force that you are bending the rod. All the while having your customer take a look at the load display, and you will see that there is no appreciable change in that load display. They might not believe what they're seeing. So ask them to place the 100-gram weight back on the scale and pull with that same force again. They will see the 100 grams on the display with no change as they're pulling it. They still won't believe it. Let them pull on the string. Show them that if they pull off the horizontal, that there is a display. We are seeing a change. But it doesn't matter how hard they're going to pull, how much they're going to bend this rod, there will be no appreciable change to the load display. The MSI scale that you're using for your demonstration is made out of aluminum or aluminium. This is just to keep it light, to make it easier for you to take in and out of your customers. It is a full working model. This is the same scale that we're selling into real live applications. Challenge any of your competition to your customer to have them bring in a scale and make this type of demonstration to you. Most of our competition, almost all of our competition scales, are physically much larger. They cannot fit a full-size working model scale into a demonstration and take it into someone's office. They simply cannot do it. Ease of installation. We can install this scale by ourselves, one or two people, without a whole lot of extra lifting equipment. Some of our competition scales require external lifting equipment and building modifications just to get the scale into their building. So what I hope you've seen is an easy and quick demonstration that you can do in front of your customers, showing them the key selling points, the main technical advantages that we have over much of our competition. This may have only taken 10 minutes. It may be all the time that your customer has given you. Once he's seen this demonstration, he's going to give you some more time and talk about some potential applications. My name is Cam Clements with the Mass Dynamics Support Group in Peterborough. I hope you enjoyed this demonstration.